Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. Today is August 1st, 2025. This long podcast or videocast is a JACO state-of-the-art review published on 28 July 2025 titled Aldosterone and Aldosterone Modulation in Cardio-Kidney Disease. Aldosterone is synthesized in the zone glomerulosa of the adrenal cortex via the aldosterone synthase CYP11B2. Stimulated by angiotensin 2, ACTH, and potassium, it's also synthesized in the heart, the vasculature, and adipose tissue. Obesity increases aldosterone via the adipocyte CYP11B2 expression. It acts both via genomic and non-genomic pathways. The genomic is transcriptional mineralocorticoid receptor mediated, and the non-genomic is rapid signaling by the GPER striaton pathways. It promotes sodium retention, potassium excretion, inflammation, fibrosis, and remodeling in cardiorenal tissues. The genomic pathway is where mineralocorticoid receptor binds aldosterone, translocates to the nucleus, and regulates transcription of target genes, example sodium transporters. The non-genomic pathway involves rapid signaling via caveolin-1, striaton, and G-protein coupled estrogen receptor, GPER. The effects include reactive oxygen species, intracellular calcium, vasoconstriction. This crosstalk between pathways, which contributes to aldosterone's pathogenic effects, particularly fibrosis, hypertrophy, and inflammation. Current therapeutic options, ACE inhibitors and ARBs in heart failure, are limited by aldosterone escape. Mineralocorticoid receptor antagonists offer more complete RAAS blockade. Mineralocorticoid receptor antagonists increase aldosterone compensatory, potentially contributing to adverse effects. Non-genomic pathways and partial mineralocorticoid receptor antagonism may limit effectiveness of mineralocorticoid receptor antagonists. Therapeutic focus shifting to more selective blockade, and novel agents like aldosterone synthase inhibitors and mineralocorticoid receptor modulators. Steroidal and non-steroidal mineralocorticoid receptor antagonists. The steroidal include spironolactone, non-selective. Side effects include gynecomastia. Eplerenone is selective but less potent. Non-steroidal include finerenone, esaxerenone, osidurenone, higher selectivity, anti-inflammatory, and reduced risk of hyperkalemia. Pharmacokinetics: finerenone is a short-acting, balanced distribution, no active metabolites, differ in mineralocorticoid receptor binding, gene expression, and antifibrotic profiles. Clinical experience: spironolactone and eplerenone have shown to reduce mortality in HFrEF and mixed results in HFpEF, example TopCat. Finerenone reduced cardiovascular and renal outcomes in type 2 diabetes and CKD in FIDELIO DKD, FIGARO DKD, and FIDELITY clinical trials. Esaxerenone, effective for proteinuria in type 2 diabetes, limited global availability. Emerging combinations, example with SGLT2, show promise for additive benefits. Partial agonists of mineralocorticoid receptors. Balsarenone, partial agonist of mineralocorticoid receptor, may offer renal and cardiac protection with less hyperkalemia risk. Binds mineralocorticoid receptor differently from full antagonists. Preclinical and early human data show preserved renal function. Ongoing trials, example balanced heart failure, evaluating cardiovascular and renal outcomes. Effects on urinary sodium potassium ratio and eGFR are under active study. High aldosterone level and adverse outcomes. MRAs and partial agonists increase aldosterone levels. Potential for non-genomic effects not blocked by MR antagonism. MR independent pathways, example GPER, contribute to inflammation, fibrosis, and adverse remodeling. Persistent mineralocorticoid receptor activation from inadequate dosing may worsen outcomes, example atrial fibrillation and diabetes. Aldosterone synthase inhibitors block CYP11B2, reduce aldosterone synthesis, example baxdrostat, lorundrostat, vicodrostat. Potential to mitigate mineralocorticoid receptor dependent and independent effects. They aim for selective inhibition to avoid cortisol suppression. Early trials show blood pressure reduction and improvement in proteinuria. Hyperkalemia risk is variable. Novel delivery methods, example liposomal targeting, are under development. Lowering aldosterone level and unintended consequences. Aldosterone is essential for fluid and electrolyte balance. Complete suppression risks hypotension, hyponatremia. Need to preserve some mineralocorticoid receptor activation via cortisol to avoid adverse metabolic effects. CYP11B2 selectivity critical to avoid off-target inhibition of cortisol pathways. Aldosterone synthase inhibitors may offer therapeutic window without disrupting potassium homeostasis. Frequently asked questions. What does aldosterone do in heart and kidney disease? It promotes sodium retention, fibrosis, inflammation, worsening heart failure, and CKD. How does aldosterone signal? Genomic via the mineralocorticoid receptor transcription, and nongenomic via GPER, reactive oxygen species, and calcium handling. Why use mineralocorticoid receptor antagonists? They block aldosterone effects, improving outcomes in HFrEF and CKD. What limits MRAs? Hyperkalemia, incomplete blockade, aldosterone escape, and non-mineralocorticoid receptor effects. How are non-steroidal mineralocorticoid receptors better? More selective, better heart-kidney distribution, fewer hormone side effects. What are aldosterone synthase inhibitors? They inhibit CYP11B2 to reduce aldosterone production at the source. What is the risk of aldosterone synthase inhibitors? Off-target effects on cortisol via CYP11B1 and adrenal suppression. Key aldosterone synthase inhibitors: baxdrostat, lorundrostat, vicodrostat, oscillodrostat, DPI3. Major trial highlights: FIDELIO, FIGARO, FIDELITY, where Finerenone reduced cardiovascular and renal events in type 2 diabetes and CKD. What's the future? Combo therapy example: mineralocorticoid receptor antagonists plus SGLT2 inhibitors, targeted delivery, and antisense inhibitors. This is a central illustration from the fantastic review in JACC. If you enjoyed this episode, share it with your colleagues. When we change how we see disease, we change how we shape lives. Until next time, stay curious, stay compassionate, and keep seeking wisdom. Podcast brought to you by Master MedFacts at mastermedfacts.com.